Alright, so hello and welcome to this video where we are going to be going over the solution to problem 1b of Code Forces spreadsheets. So the time limit per test here is 10 seconds. If you do read this, you can pause the video and read this. Basically, we actually have 5 seconds, and that's just due to the judging servers. Um, so memory limit per test is 64 megabytes, and it's standard input output, so SIO. Um, and so let's read the problem here. In popular spreadsheet systems, for example in Excel, the following numeration of columns is used. The first column has number A, the second number B, till column 26 that is marked by Z. There are there are two letter columns. Column 27 has number AA, 28 AB, all the way to 52 with AZ. After that, there are three-letter numbers, and then so on and so forth. The rows are marked by integer numbers starting with 1, so the rows are pretty simple. The cell name is the concatenation of the column and then the row numbers. For example, BC23 is the cell that is at column 55, row 23. Sometimes another numeration system is used. So for example, RXCY, where X and Y are integer numbers showing the column and row numbers. For example, R23C55 is a cell from the previous example. So this would be row 23, column 55. Your task is to write a program that reads the given sequence of cell coordinates and produce each item written according to the rules of another numeration system. So what this means is if we're given, so actually first let's read. The input contains integer number n, the number of coordinates in the test. Then there are n lines, each contains coordinates. All the coordinates are correct. There are no cells with the column and or row numbers larger than 10 to the power of 6. So each line should contain a cell coordinate in the other numeration system for our output. So if we're given an input of 2, then R23C55 would give us BC23. Okay, so now that we've got that covered, the path is actually pretty straightforward. Step 1 is to check if it's in this format or this format. So if it's in, we're going to call it RC format or Excel format. And then step 2 is to extract the numbers if it's in RC format. And if it's in Excel format, we just need to split first the letter, then the numbers. And once we've done that, we can then convert. So what we'll do is we'll take the row number is same between both of them, so we don't have to change it. For the column number, we have to, if it's from RC format, we have to convert it into a 26 decimal format. And the way we do that is we would use just constantly dividing by 26. And the other way is we just multiply by powers of 26. All right, hope that makes sense. So now what we're going to do is quickly go over the logic basically inside a paint tool so that we can kind of understand it a little bit better. All right. So here is our document. So basically we will be starting off with our inputs. So for the time being, we're going to take the R23C55, so R23, and then C55, right? I can do that a little bit better, so why don't I get work on that? So basically, we'll start off with, if we start with something like R23C55, then we can use a regex expression to check if we've got these two components. And if it does, we can then use regex to extract this and this. And just to be clear, that's this. So the numbers we can extract again using regex. And I'll just be showing you guys how very soon. And then what we want to do is, we want to, we've got this value, and we just need to, so we got 23 here and 55. So the row is the same. We don't need to actually do anything with the row. So we will take this 55 and we'll split it. So we got 55. So step 1 here is to divide by 26, and this is going to give us 2, I believe. Yeah, 2, or is it 3? This should be 2 remainder 3, is if I am correct. This will give us a 2 with the remainder of 3. Um, I'm just checking one thing. Yeah, so this will give us 2 with the remainder of 3. Then we're going to say this 2, and we're going to say this is B. And then this 3 is going to get pulled down here, and we're going to say 3 over 26. Well, 3 is less than 26, so that's just going to give us a remainder of 3, and so this is going to give us a C. And so what we're doing here is we're just using a standard, and this is a mathematical method of converting to a base 26. So let's just go here. So if we look over here, what we can do is we can say convert number to base 26. So to convert a number to base 26, you just use the letters of the alphabet. And the one thing I do want to make clear is we will be shifting it over. Um, so row 1, um, basically row 1 is A. Actually, no. So yeah, theirs is correct, except we're going to do column 26 is Z. So one of the actually other things we can do is we can iteratively increment. So this is actually smoother dividing. So there's 2 ways to approach this. So the first way is the way we said, so where we divide by 26. Now, if it's perfectly divided into 26, we take the quotient. Wait a minute. Sorry, give me a second. Alright, so here is a really good website which explains basically what we're going to be doing. So base 26, they're going to show how to convert, for example, this number, 1208. So 1208 will basically be converted as shown. Alright, so hopefully you've had enough time to read this. Sorry if you couldn't see what we're doing here. Basically, what they're showing is this is 1, 20, and 12. And that's going to give us our what we want as 1208. So now they're showing here something important. If we use A equals 0 style, then code ATL is really B, and then they say you figure it out. Now we are going to use an A equals 0 style. Actually, no, not really. So what we want here is we have 1 to 26, but whenever we see something that's divisible, for example, by 26, it should not be an A and then a Z like they've shown here. So if we go back here, and if I put 26 into the 26 letters, they're putting AZ. We don't want an AZ. If it's 52, that's a BZ. We don't want a BZ, right? So if it is 52, for example, let's take that example. That would just be B. Uh, right? That would be B. No, would that be BZ actually? No. So Z would be, so 26 would be Z. 27 would be AA. All the way up to 52 would be AZ. So if we have an AZ, so if we ever find a Z in the middle, right? So So one could actually argue that we're using a base 27 system. So once you get to 27 is a 26 is Z. So the problem with this numbering system is we don't really have a 0. We just have a 10. And we just have a 26. So if it's a 26, it's a Z, right? So actually converting, so let me go here. So converting in this method that we had shown here will be difficult. Um, it will be difficult. It'll be faster. The other way we can do it is find the largest power of 26 that fits within that row. So for example, that would be 26 itself would be the largest power. So then find the largest multiple of that power. So for example, that would be 2 times 26, which would give us a 2. And then when you subtract 55 minus 2 times 26, you get a 3 largest multiple. And then you can just sequentially go down. So largest multiple, this is going to be 3. So I actually think this works a little better. Now to quickly find the largest power that works, we can use a logarithm. So we can say log base 26 of 55. And as a final note, if we do see that 26 fits in a perfect 26 times, in typical notation, you would say that this would be 1 time 26 fits in. In this case, we don't say that. So this really depends on what's in this case. Again, this makes it quite difficult to convert actually. Now there actually is a way we can get around this. So what we can do is, instead of saying the largest multiple that fits, we can say the largest multiple that is less than and strictly less than this number. So what that will do is if we have 26 the largest power that is strictly less than 26 is 1, which will give us a 26 here. Let's say we had something like 55. The largest power that's strictly less than 55 is 26. So the largest multiple that is strictly less than 55 of 26 is 2. And then you can go here to 3. Once you get the ones digit, you just put it down. So what this does is if we had 52, the largest multiple strictly less than 52 is still 1, right? So what we do is now that we have 26, we subtract a 26 here, we get this 26. That's no, and that's the key thing, is that once we hit the ones digit, we have to put a 26. And that's going to give us AB. So then that brings the question, can you ever have something like AZA? And that would be 1 plus 26 plus 26 squared, plus 26 squared. Sorry. 1, that would be 1, so 26 squared, 1. And the answer would be, yeah, you'd want to stick with AZA, because this would technically be BZA, but we can't have this BZ right here, right? Because this BZ in our notation doesn't mean 2 times 26 squared plus 0. In our notation, it actually means 2 times 26 squared plus another 26 squared, which is not what we want, so we have to subtract this by 1. And so then if we had AZZ, is this possible? And this is 26 squared, and this is 26 squared. And this is possible. The main reason why this is possible is that it's an overflow cap, right? You can only have a maximum of Z. So this number right here would be 26 squared plus 26 squared plus 26. So actually what you'd end up with is BAZ. So this makes things a lot more complicated, actually. Right, so now that I've got this, it just actually seems best to create a cap, to create just an iterative going through each time. So 55, we need to add 55 here. So we start off with 0. And when we add 55, we add 26. That gives us Z. Then we add another one. So basically, we would just keep adding. So we would start with A and 54, right? Column 55, so column 1. Now we have 54 more, so B, then C, D, all the way to Z. And then once we hit Z, we go to A, A. So Z basically acts like a 10. So whenever you see Z, you multiply it by, that's a 26. Hmm. And the problem is this makes converting to from the Excel method to the row method much easier. But from the row method, from the RC notation to the Excel notation is very difficult. So now it appears we're stuck. So one of the best things that you can do at this time is actually just look for inspiration. So if you aren't in a contest, then you can do this. If you are, you would have to come up with it by yourself. Um, and that can be a little difficult. So that's why it's actually good to practice. But for now, let's. So I've searched it up and I got this, and this is actually exactly what we want. And so what they're showing here is, and this is in C sharp, which is pretty similar to Java code. So we can pretty much understand this. So we have a column name, which we're just going to make an empty string, and a modulo. So while the dividend is greater than 0, modulo is the dividend minus 1% 26. So that's going to be our modulus. And then we add 65 to the modulus, we convert it to a string, and we get the column name. And we add that to the column. So we're appending in front. And then we divide the dividend, subtract the modulo, and divide by 26. And we just keep doing that until our dividend is empty. So this code is actually relatively simple and easy to implement in Java. So the reason I say easy to implement is because in Java you can add numbers to characters. And just quickly to show that, we're going to head over to IntelliJ, where I'm going to show you guys, and we can actually get started. So rows exception, and this is just to quickly start it up. That is not what I wanted. IO exception. There we go. So it throws an IO exception, and that's just for our buffer reader when we input it. But for now, we're going to say car character is A, and then we're going to say character plus equals 2, and then we're going to print out character. And you'll see this should give us C. Right? So this gives us C. And we can pretty much easily do that. So, and then we can obviously, if we had a string str is this, we can say string is character plus string. And now if we did it, and we printed out the string, it gives us C, because we have added to the character. So what we can do then, what we can do here is we can put this in parentheses, and we can say character plus our modulo, that can be, say, 5. And now we're going to get output, so A, B, C, D, E, F. And it didn't work. So let's check character plus 5. If we do, yeah. So what we would do then actually is we would create our character cur is a, and then we would say cur plus equals 5, which would be our modulo. Kind of similar, basically what we did with the character. So yeah, and that's kind of how we would go about implementing it. So now all we have to do is just implement a buffered reader. And a string tokenizer, and this is going to tokenize it for us like we always do. And that's st.nextToken. This is f.readline. And what we're going to want to do is say int n is integer.parseInt of st.nextToken, and for I, and this is going to be a for I in n, and we're going to say string is new. Sorry, is not new. It's sorry, give me a second. It's not new. It is just going to be integer dot parseInt of st.nextToken, and we don't want to parse that int, so we could have just used st.nextToken, and this should give us the new string tokenizer of f.readline. That part's pretty important. So that's our string. We're going to use a regex implementation now. So we're going to say pattern. Pattern is pattern.compile, and we just need a regex expression here. So the regex expression we're going to use is r//d plus c//d plus. And so what does this mean? Well, r basically means it's going to check if there is an r. The //d plus, so this means it's going to check if there is one or more digits, and that's going to be till here. And then a c is going to say, then there's a c, and then //d plus is going to say if there is one or more digits. So then what we're going to say is if pattern dot matcher of string dot find, and this is saying if it has been found, then we're going to say pattern extract is new is actually no, it's pattern again, the same thing, pattern dot compile of, and this time we're going to say either r or c, and then //d plus. And so what this is saying any of the characters inside r or c, inside this, so that's going to be r or c, and then this parentheses means it's going to take that as an extraction. It's going to extract that out and put that in a grouping. So then it's going to say //d plus. Now the thing we actually want to do is say here we want to get every instance. So we're going to say while pattern, not pattern, extract dot matcher of string dot find, and we're going to initialize an a to -1 and a b to -1. I'm going to say if a is equal to -1, then we're going to say a is equal to integer.parseInt of and actually no, here we want to actually create a matcher. So we want to say matcher is this extract.matcher of string and then we're going to say matcher dot group of 1. And then otherwise, B is equal to the same thing. So this is going to extract both of our information. So what it's going to do is it's going to say if it's finding a new one, we're going to get the group and get that integer, and matcher.group of 1 basically gets that group, gets that what we're searching for, and then it pulls that off. So then we're going to go back into it. It's going to say, are there any other instances of matcher.find? And yes, there are. We should have 2 of them, one here and one here. And once it finds it, it's going to say, okay, then B is equal to that integer. And so this is going to extract both of our A and B. Our A and B are actually our row and then our column. Now, like we said before, our row doesn't really matter, so we can keep that aside for the time being. Our column is what we want to use. Now, we're going to say that for the column number, we've got the dividend, and that's just B. So then we've got a string, so we're going to say a string, and we're going to say CNAME is just an empty string, and we're going to define a modulo, so int mod. Now we're going to say while B is greater than 0, we want to say mod is equal to the B minus 1 %26, and so that's going to be our mod. Then we're going to want to say column, we're just want to say car C is A, C plus equals mod, and then we're going to say our CNAME is basically C plus CNAME. And finally, we're going to divide it by 26. So we're going to say B is B is going to be our B minus mod divided by 26. And boom, we're done. Now this is going to give us our CNAME, and what we're going to want to do is system.out CNAME plus A. And that's that. That's the basically our pattern there. Now the other way we do it, we go the opposite way, is much simpler. So we say else, it's not going to do that, so we want to extract a regex. And it's going to be a similar regex. We're going to say, first we want some digits, so we're going to say pattern extract is going to be a pattern.compile, and we're actually going to want not an R because it's not. It's going to be something from in the range A to Z, and one or more of them, and then something in the range A to Z, 0 to 9, so //D plus what, right? So this is going to be our pattern. So the first thing we want to find is A to Z, and we're going to say basically what we set up there. So matched is extract.matcher of string, and then if matched.find, and this is going to be first our string lets us, and then we've got an int call. Oh, wait a minute. Yeah. So our string lets and then our int row. And if we find, so we're going to find it. We know that for sure. So what we can do is we can just put parentheses here, and that's how we're going to extract. We're going to say match dot group of 1, and we're going to get, that is the row. That is the let's. Now we're going to do the same thing here. We're going to say extract is pattern.compile, except this time it's going to be a // d plus. And same thing here, we're going to want to say matched is this, and then we're going to want to do this, and finally we're going to say this is not, this is actually integer.parse int of matched. And that's going to get us our letters and our rows. So our row we don't need to touch. For our letters we just iterate through. So for car C in our let's dot to car array, what's the problem here? Oh, okay, sorry. Right? So for car C in let's dot to array, so first step is to say int num is going to be, if it's an A, we want to say 1, all the way to Z, we want to say 26. So the way we can do this is we know that an A is going to be a 65th one. So we can say int num is equal to C minus 65 plus 1. And then, rather, num plus plus. Now what this will do is this will give us that it is that is A. That's an A. If it's an A, then it's going to be C minus 65 is going to give us 0. And we don't want that. We want a 1 because remember A is 1. And so num plus plus. Now we can have our int call is 0. So we what we would want to do is multiply the column by 26 and then add num. So call times equals 26, call plus equals num. And this is standard base conversion back to 10. We're multiplying it by 26 and then adding back num. And that is the simplest way that I can think of to convert back to this. And then we can say, we can system.out. First we need R, and this is going to be a capital R, plus row plus C plus call. And again, they're going to say row is not initialized, so I'm going to just set that to 0. And this is going to repeat for each 1 in n. So now we can compile, and hopefully it should work. So what we're going to do is go to here, and we're going to just copy this, and let's go here, and paste. So boom, it seems to have worked. Let's try our own one. We're just going to say 1. And the thing that I'm really curious to see is how it handles R52, C52. So, that's not good. It shouldn't be saying AZ. It should be saying BA. So let's see, how can we fix that? Hmm. Hmm. So going back up here, and we're just gonna take a look at it. We want to set the mod to b minus 1% 26, and then the character to a. So, and then we want to add the mod to it. And we update it, and we divide by 26. So I don't see, I'm a little confused here as to how we can convert this to BA, right? Because 27 shouldn't be, 26 right here, a 52, would that be AZ is my question. And it actually, no, that would be AZ. Sorry. Let's try R53, C53. Sorry, this should be 1, Java compile. I think something happened, so Java CF1B, 1, R53, C53, BA53. Great, so it actually works. And I was stressing about nothing. We're gonna go 1, and just to quickly confirm that it works when we go backwards, I'm gonna say ZZ. So this is giving us hmm. This is interesting. This might not be getting what we needed. Let me try this one second. Oh, I didn't. Oh. So it's saying it's getting ZZ, which is good. Oh, I see why. I see why. I see why. I forgot to input the column, which might have broken the entire thing. So this is going to be R1C. Yeah, R1C702. 702 seems to be correct. Yeah, let me just quickly check if that's correct. We can just go here. So we can just say 26 squared times 20 plus 26 is 702. Great. So it seems to work pretty nicely. Hopefully it can handle huge inputs. Sorry, don't know why I copied that. However, oh, I do not seem to be logged in. Give me a second. Okay, so let's choose my file, and I'll be right back. Okay, so here it is, submitting, and it's in the queue. So I will let you guys know when it's ready. And it's accepted. Look at that. So right here you can see it's been accepted. And yeah, that was basically it. If you guys did enjoy, please don't forget to like and subscribe, and I'll catch you all in another video. And here's a quick rundown of my code if you guys wanted to see it one last time. Alright, that should be it. See ya!